All right, so let's take a look at what our classwork is. Figuring that we're doing real life stuff, what I did was I just went on the internet and I found an actual floor plan for an actual one-bedroom apartment with a den in Laurel. So, since we're doing a lot with the cost of living and homelessness and poverty, what I decided to do is figure out how much you would really have to make in order to afford this apartment comfortably. Okay, so right here you've got the monthly rent is $1,334 per month plus a $300 deposit. Okay, so at the bottom, I just want to take a look at right here. Your total rent is $1,334 per month. Okay, in order to live comfortably, I'm just going to double that so that you have enough for food, for utilities, for transportation, for whatever, internet, cable, whatever. So we're just going to double that. That becomes $2,668 per month that you have to earn in order to live in this one-bedroom apartment, okay? Then you figure that's how much per month you have to earn. There are 4 weeks in every month. That means that you have to get paid $667 per week in order to afford this apartment, okay? You figure that the average person works about 40 hours per week, which makes it down to an hourly rate of $16.67 per hour in order to afford this apartment comfortably. Now, take into account that the minimum wage in this country right now is $7.25 an hour. So if you are making minimum wage, you may not afford this one-bedroom apartment. And we're going to look at the dimensions of the bedroom at the end of the class period. Okay. All right. So I'm going to give you a little piece of information that may help you. At the top, you see where it says 1 bedroom, 1 bath with den, 1 bed, 1 bath, and it's a total of 1,485 square feet. So you may want to put that on the top of your paper, 1,485 square feet.
And Ms. Thompson, I'd like to just refresh, I'll bring us back to Change Matters. If you were making $16.67 per hour and you lost your job, would you be able to maintain this place if you got a job that was 7 hours and something? No. So you have to
Definitely
think
not.
about that. That's what happens to people.
Right.
You could try to double hours, but then you might take yourself out because you can't sleep.
Right. Also, I just saw the other day that Walmart starts their employees at $11 an hour.
Still could
Yeah. Yeah. That's starting. And you think to yourself, wow, $11 an hour, that's like $4 more than the minimum wage. Yes, sir.
Did you get it?
Could I? Personally,
No, like even if you made $11 an hour.
You could. It would be real tight though, wouldn't it?
Yeah.
Yeah. It'd be tight. It'd be tough.
You could still get it with like $10 an hour because you could only not get it if you made anything under $8.50 you could get it.
Correct.
Because that's half.
Yes, you could. Yeah, you could. It would be real tight though. You wouldn't have any money for food, for utilities,
Yeah.
water.
Just gonna get it.
Couldn't. Yeah. You could not live. I mean, you can pay the rent, but that's it.
You have a space, you have shelter.
Yeah. All right. So let's flip over to our second page. What you're going to need for this classwork is a pencil, a ruler with centimeters, which I will pass around in just a moment, your drawing for the apartment floor plan, which is your first sheet, and the scale for the apartment. Okay? Our scale for the apartment is 1 centimeter on our drawing is equal to 3 actual feet. Okay? So, if I'm writing this scale as a fraction, what is it going to look like? If I'm writing the scale as a fraction, Ben.
I'll put a 1.
Okay, you're gonna put 1. Then what?
Fraction bar.
Fraction bar? 3. Okay. What are these? 1 what?
Oh.
Yes, Ben.
Oh, so for the top should go centimeters.
Centimeters. Okay.
Bottom
1
should go
centimeter.
Feet.
And then what in the bottom would be feet. Okay. Can I put 3 feet is equal to 1 centimeter? Is that okay?
Yes.
Can I do that? Why can I do that, Quentin?
Well, it works the same way.
It works the same way. As long as I keep the feet on top, if I put the feet on top over here, then I gotta keep the feet on top on my second fraction. Okay. So as long as I'm keeping my centimeters on top and my feet on the bottom, I am okay. I can set it up however I want to. So this is our scale right here, okay? All right. So our first question, how long would the 10 centimeter side of our floor plan be in real life? How can we set this up so that it looks like a proportion? First of all, should we put centimeters on top or feet on top? Ernesto, what do you think? Feet on top or centimeters on top?
Feet on top.
Feet on top? Okay, let's put the feet on top. We're going to put feet on top, centimeters on the bottom. So, that being said, what does our first fraction look like? What does our first fraction look like? Kayla?
3
3 feet?
over 10.
I disagree slightly. We're just doing the scale, so what does our
Oh.
scale look like?
3 over 1.
That's right. We're going to keep our scale the same no matter what, okay? Then, we've got to find an equivalent fraction in which 10 is going to be on in this fraction someplace. So, what is my second fraction going to look like? Megan.
It's going to be x over 10.
Okay. Why do you pick x over 10?
X is a variable since we don't know what the heat is.
Yep, that's right. So remember that we're trying to create, see this equal sign right there? They are equivalent fractions. They are equal fractions, okay? So we've got to create an equal fraction in which 10 is going to be on the bottom, because remember, you got to keep your feet together, okay? So then once I have these two fractions, these two proportions, what is my next step, Jalen?
I know what x is.
Okay, well wait, what's my next step? Let's take this step by step. Okay, you could cross multiply, and when you cross multiply, what are you going to get as your equation? Ernesto.
You could get 30.
I disagree.
I mean,
the whole equation.
X.
Yep, so x, because
And
it's
then
1x, but do you have to write the 1?
No.
No, because there's still one of them.
then
Okay,
you multiply.
equals
And 30.
30. Okay. Can I set this up another way? Once I have these two proportions, can I set this up a different way and get the same answer? I did cross multiplication. Is there another way that I can solve this? Muna?
Once you have those two,
These two fractions, they got 3 over 1 and an x over 10. How else could I solve?
you could just multiply 3 and 10 and get 9.
Could I? Who said ratio table? Who said ratio table? Who said ratio table? Somebody said ratio. Daniel, thank you for saying ratio table. So we could make a ratio table. Remember that we have a graded classwork, so if I ask you to make a ratio table, it might be nice to have an example of one. All right. Here's our ratio table. We've got feet on the top, centimeters on the bottom. We're going to put centimeters as 1. It's our scale. 1 centimeter is 3 feet. Which means that 2 centimeters is what?
6.
6. Which means that 3 centimeters is
9.
9. Very good. 4 centimeters is
12.
12. Oh, you guys are awesome. Gotta meet some more boxes here. Hold on. 5 centimeters is 15. Am I close yet?
No.
Oh,
Not there
goodness.
yet.
All right. So can I take this? Can I take this up by a number?
10.
Yes. You can go by
2.
By 2. I can multiply by 2. When I multiply 5 times 2, I get
10.
10. When I multiply 15 times 2, I get
30.
Okay, make sense?
Yes.
All right.
I need a rule.
So, with number 2. Okay, so right now, on a scale of 1 to 5, let me see how many fingers. If you think I may as well be speaking Chinese, you hold up 1 finger. If you think I got this, I'm okay, you hold up 5 fingers. So let's see how many fingers we got. Everybody got this? Loving it, loving it. Okay, 3s, 4s, 5s.
10.
Right on. Okay, so right now, what questions do you have for me first before you continue with your classwork? Ben.
Happen to notice up there in front of feet, x equals 31.
Oh, thank you for attending to precision. You're so awesome. 30 feet. Thank you for attending to precision. All right, what other questions do you have? Muna?
It's not necessarily about this, but why do people cross multiply?
Okay, do you want to know why people cross multiply? Because if we are saying that these two are equivalent fractions, okay, this one is the equal sign indicates that those two fractions are equal, okay. So what we are doing is when we cross multiply, what we're doing is figuring out. So if we're just using numbers, let's say 3/6 and a 1/2, okay. If we know that they are real numbers, okay. If we cross multiply these two numbers, we would get 6 on the top, and if we cross multiply these numbers, we would get 6 on the bottom. So the idea is that they all relate to the whole. Okay, you got parts and you got wholes. This part and this whole is the same as this part and this whole. And when we cross multiply, that proves it because we get the one whole. Does that make sense?
Yeah.
We've just divided something into 6 pieces, and we're talking about 3 of them. Or we've divided something into 2 pieces, and we're talking about 1 of them. Right? So no matter what, when you cross multiply, you're going to make one complete whole. Okay? You good? All right. Ernesto.
Why can't I do it straight?
Because they are equivalent fractions. Okay? So if they are equivalent fractions, remember we're comparing parts and wholes, right? This is the part and that's the whole, right? So if we're going to, what tells us to multiply straight across? Does anything tell us to multiply straight across? Is there a multiplication symbol in there someplace?
Like the. Then you cross multiply.
Yeah. You would cross multiply because what you're doing is dividing. So the opposite of dividing is multiplying.
Oh, divide.
Multiply? Yes.
Multiplying.
Okay. Kayla, one last question.
So when you're turning your scale into a fraction,
Yep.
does it matter which one you put on top?
Doesn't matter. As long as you keep the units the same, right? So as long as you have the feet on the top, so you have feet here, centimeters and centimeters.
Oh, that's
Could I flip it over? Yes, I sure could. I could put 1 centimeter and 10 centimeters and 3 feet and X feet. I could do that too. It doesn't matter. As long as I keep them the same on all the centimeters on the top or all the feet on the bottom. Okay?
So I was doing my homework the other night, and like I would put the what do you call it? The different units
Yep.
on top.
Yeah, don't mix
and
them up.
Raquel told me that it was wrong.
Yeah, you don't want to mix them up.
And I didn't like.
Yeah,
really
it's like apples and oranges. All right. So, for this one right here, for number 3, you are going to need a ruler. So when you get to that part, raise your hand and I will come around and give you a ruler. Then, what I want you to do is skip this one because this will be your homework, but not for tonight. Instead, measure the living area in centimeters. Measure the living area in centimeters. So you're going to measure from the inside wall and then figure out what the actual dimensions of the living room are. I don't know if we're going to get to that or not, but we're going to give it a shot.
You measure in centimeters.
In centimeters on your map, okay? All right, let's do it.